So for this video, I'm going to show you how to use AI models that are open source and open source software to sharpen images, and you can get some fairly decent results with this. So I'm going to walk you through the process of both creating an upscaled image, then I'm going to show you how you can then use some open source software to use that upscaled image to create a sharpened version of the image, and then I'm going to apply that back to the original to show you how you can get the effects of sharpening without the kind of artifacts that sharpening an image would use without the AI. So let's look at the process, and I'm going to show you some before and after results, and then I'm going to sharpen the same image just using some sharpening tools without the AI, just so you can kind of have a point of comparison. So to show you what I'm working with here, I have a couple of images I've already generated, but the original image is this one right here. And this image I shot about a week ago. What are the best conditions for shooting? And I saw these birds up in a tree, and I thought, oh, maybe that'll make an interesting image. And I just wanted to try it. And I went inside, got my long lens. I have a 500mm lens, and I put a 2x extender on it, and I handheld it to shoot this image. And so I got these birds up in the tree, and the image is kind of noisy. It's not the sharpest image in the world, but I think there's enough here that I could probably bring out some of the details in this. It's not so far gone that I can't work with it. But if an image is so far gone that you can't work with it, there's not much more you can do with it. But I think this has enough detail in it, and it's not so like out of focus that I can't work with it. So there's enough here. So that's my goal. Is I'm going to try to bring out details by sharpening it, but I also need to denoise it as well so that I can not get a lot of artifacts in the image by sharpening it. So that's where the AI is going to come into play. So let's work with this image, and let's use Chainer to upscale it. If you've never worked with Chainer, it's basically a little application that allows you to build workflows. And it's designed to do many common things you can do on images. But one thing you can do with it is use AI models to upscale or manipulate images. So I'm going to be using an AI model here. But if you are interested in this app, it's free, it's open source. So I'm going to put a link in the video description down below if you want to download it. And once you download it, you come over here to Python, and it will have options to download some of these modules. I'm going to be using PyTorch for mine, so I'm going to be using PyTorch models. So you have to install Python to do this, but then PyTorch will then be installed alongside all the dependencies it needs. And once you have it installed, then you don't need to ever install it again for the application. You might have to update it, but otherwise it's installed. Once it's installed, you hit Restart Chainer, and it's ready to go. And this will enable you to use your GPU or your CPU. I recommend using a GPU if you can, because the CPU will be very slow, but I have an RTX 3060 on this machine. If you have an older GPU or a newer GPU, it should work fine, but I'm using this one for mine. But once you have it, you hit Restart Chainer, and everything is good to go. So a couple of operations that we're going to be using are load and save image. And so that's working with the images. So I'm going to load an image and save an image, obviously. And I'm going to be using some stuff down here under PyTorch, which is basically to load a model. And I'm also going to upscale using this particular model right here. So let's see, I need to type upscale here. Upscale image, there it is, under PyTorch. And now this is a real simple interface to use. Basically, you drag these things onto the canvas here, and then you just link them together using these color coordinated nodes. So I'm going to load an image, send it into my upscale image. I'm going to load a model, send that up to my upscale image. And then I'm going to take the output from that and put it into save image. And now with this, you can save this workflow as is, but you can also save it with a parameter. So I'm going to load a model here, and I have a models folder, and I'm going to be using this one called Real. Where is it? I have it already downloaded here. So I'm going to use Real Esgrand 4X X4 Plus. And so that's a pretty decent model for what I'm going to be using. And it basically does a decent job of upscaling it while removing the noise. So I'm going to use that model, and it's going to load it up into memory. And for my image, I'm going to use that source image that we used here. And that's going to give you the preview. And now I can then write it out to that same folder. If I want to choose the directory, sure, select that folder. For the name, you can just choose the name of the model, or you can type in a name. So I'm going to call it the name of the model so I know what I'm dealing with. And since I've already done this, I can basically write this out. I already have the image produced, but I'm going to save it as a TIFF. And you can use 16-bit 8-bit, whatever you want to use. And once you have all this ready to go, you hit play, and it takes a few minutes to upscale it, but it's going to upscale it and it's going to write out the upscaled image to this folder right here. And if you want to save the workflow and load it again, you can just simply save as, and you can save the workflow. I have one already saved, so I'm going to open up mine and just open this one. I'm not going to save it. And you can see that I have this workflow right here from another example. The only thing I need to do is nuke that, resize, because I don't want to resize it for this operation, and just change the parameters like that, and then I'm ready to go. But I can, of course, set this back to my image that I was working with, which is this image here, but that otherwise Realize Grand X4 Plus is my model. And this is exactly what we saw before. If I want to use 16-bit, that's probably what I'm going to use. And hit go, and upscales the image. So wait for that to finish, and once it's done, you'll have an image that you can work with. So I'm going to show you the results of this now, and I'm going to take it into GIMP. So I've opened up two different images as a point of comparison. This is not the model I used, but I wanted to open this one to show you kind of what we're talking about here. So this is one that I used an AI upscaler to produce an upscale version of the image. And this one doesn't do a good job of denoising it. In fact, it adds a lot of texture to the image, which I want to try to avoid. I want it to look more like this one right here, which is Realize Organ X4 Plus. And if I zoom in on this one, you can see it's a rather smooth image. Now, it does kind of mute a lot of the contrast when you do that. But that's okay, because we're not going to be using this as our final product. We're actually going to be working with this. We actually want less noise when you sharpen it, because if you have a noisy image and you sharpen it, it just makes the noise amplified. So that's what we're trying to avoid with this one. So I've got this pretty zoomed in. It's not sharp yet, but once we sharpen it, I think we'll get some pretty decent results out of it. So I've already opened up both these images in GIMP, and I have the original right here. And I have the upscaled version right here. So the upscaled version is the one I'm going to be working with. So I'm going to zoom in, just show you that's kind of what I'm talking about. I have this nice smoothed out image. It's been denoised. Now I want to sharpen it in its upscaled state. The reason I want to do it in the upscaled state is because I actually want to over sharpen it here. And the reason why is if I over sharpen it here and I scale it back down, it's going to lose a lot of the artifacts that I get when I over sharpen things. And when I blend it with the original, it creates a nice mask to put on top of the original that gives me some nice details. So to show you how this works, I'm going to first just apply a unsharp mask to it. And this will give me the ability to sharpen it. Now, the values that you use for this is largely discretionary. I like to maybe set it up to about somewhere between 8 and 12 for the radius, because it's a rather large image. And the amount, maybe around 3 to 4, depending on how much sharpening you want to do. And if you're in doubt, you can always repeat this process and see what works best. So over sharpening is advised here too, because you want to have some good hard edges, and that's really what we're going for here. So increasing that localized contrast is really the name of the game here, so that we end up with a image that looks over sharpened and intentionally so, and you end up with these halos around it a little bit, and that's okay, because we're gonna scale this back down, and we're gonna hopefully reduce some of that too when we do rescale. So I'm gonna back this radius back a little bit and reduce that halo just a bit, but I'm still getting some nice hard edges, maybe a little bit more, and around 10. That's looking pretty good there. And then I might bump up the amount a little bit, and that's got some nice hard edges without being too overly sharp as well. So let's do a little bit more, and that's good. Okay, I'm gonna click OK, and that's going to apply the unsharp mask. Now if I zoom out, the image right here zoomed out looks decently sharp like that, and that's because I did a nice job sharpening it, but it doesn't have a lot of the nuances that the original image has, because it's kind of been sucked out of it, if you will, by denoising it. So this sharper image right here combined hopefully with the original image will give me detail plus sharpness, and so you can get a nice blend of the two depending on what you're trying to do. So the next part to do here is to transform it. So we're going to scale it. So you go to the scale tool, and you're going to scale by percentage, because we did a 4x upscale. We're going to scale it by 25%, which is 1/4 its original size, and set your interpolation to low halo, which is basically removing halos around the artifacts whenever you scale something down. So set it to no halo, and then you hit scale, and that's going to scale it down. And this can take a while depending on the image. So this is the results of the downscaling, and that can take a minute to complete. But once you have this, you can see that it's been reduced by 4x on each edge here. So you end up with something that looks more like a tile, but that's actually the original resolution, and the AI upscaled it by 4 times on each edge, but it increased the overall size of the image quite a bit. But if I take that and go back to one of the originals that I have open here, I opened up 2 instances of it. I'm going to paste in that scaled down version, and I am going to paste it in and then turn it into a layer. And so if I zoom in on this, you can see that it's the upscaled version of it that I had, and it's been denoised quite a bit, maintaining some of that. And now I just want to blend it with the original image, because this one looks over sharpened, which I kind of want that. To do that, I just set the opacity on the layer. So this is without any sharpening. And if I slowly increase this, you can see that it's kind of bringing through some of that sharpening that I did without making it look like it's over sharpening, but also without introducing a lot of extra noise in the image as well. So right around 40 to 45% is probably good for this image, and I think it gives it a nice sharpening without looking like it over sharpened the image too much. So it still preserves some of the detail without introducing a lot of extra noise as well. So, and you zoom back out and you get a result that looks something like that, which I think is an improvement over the original that we saw whenever we were looking at it without the unsharpening. Now, to show you what it would look like if I didn't do the AI upscale and all that other stuff, I'm going to sharpen it using the same process. Basically, I'm going to go into filter. This is a noisy image. I could try to do something similar with this. I could try to just enhance it using the unsharp mask. But if I do that, you can see that it's amplifying the noise, which I kind of want to avoid that if I can. So you could attempt to denoise it by enhancing it. You can do a despeckle right here, or denoise right here. Despeckle or denoise depends on whatever your preference is. I don't like this one because it's pretty destructive of detail, and you end up with something that's kind of even more out of focus than before. But then you can go back in and try to apply an unsharp mask to it to try to bring out some of that detail again, but it's probably going to increase noise even more with some artifacts, still having a lot of artifacts from the noise. So I'm not a big fan of using that approach, but it doesn't, it's, in a pinch, it's probably fine. And that's just using some algorithmic approaches. So when you compare the results, I think this one ends up being a little bit sharper overall without adding the noise back into the image by using AI to do that. So you can try to play with this some. It's just a fairly straightforward method of using AI upscalers, open source software, and stuff like that. And I'll link the model I use in the video description, as well as GIMP and Chainer. And you can use these tools and hopefully can sharpen up some of your own images if you so choose. And as always, thanks for watching. Like and subscribe and share this video with your friends. And I hope to see you again.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.